Okay, so now we're going to talk about domain and range, and we'll continue the conversations we've had about functions. So first off, let's just kind of reiterate the talk we had about functions. So can I ever draw a vertical line that crosses this more than once? No. So it's good. So that's a function. Now, let's talk about domain and range. And there's two ways you can express domain and range. We'll mostly do interval in this class. You'll occasionally have to deal with set notation as well, so I'll teach you both. And I'm going to go all these by interval first, and then I'll go back and teach set notation, okay? So for domain, domain deals with the collection of all the x values. So domain deals with the x. And so when you think about x, x is left to right. The horizontal axis is left to right. So I'm going to ask myself, when I'm looking at this graph, how far left will this graph go? Okay, now think about this. We got arrows on the end. So arrows on the end means it's going to go forever and ever. So forever and ever to the left, I'm talking about the domain. How far left does it go? It goes forever and ever to the left. If I were to go forever and ever on this number line to the left, I would be going to negative infinity. Okay, infinity is how we express value meaning going forever and ever. It means it's not stopping. But if I'm going forever to the left in the negatives, it'd be negative infinity. So you're going to do an open or a parentheses, negative infinity. Now, we do a parentheses because it's not an exact location. Okay, if it is an exact location, we do a brace. All right, comma. So that's how far left I go. Now, how far right do I go? So how far right does this go? So when does this graph stop? Well, you notice it's going forever and ever to the, so I go forever and ever to the right. So how far right does it go? When does it stop? It never stops. So it'd be positive infinity. So you ask yourself, how far left for the lower bound? How far right for the upper bound? Now, occasionally you have situations where there's gaps in there and you have to put gaps in there. We'll talk about that as it comes, but for now, we're just going to be mostly dealing with um, graphs that do not have gaps in them. But how far left to how far right? That's your domain. Okay, it deals with the x. Range deals with the y. So for the y, we ask ourselves two questions. How far down does it go? To how far up does it go? So range of the y is the up and down vertical axis. So how far down? So how far down does this graph go? Well, it goes down forever and ever, so it'd be negative infinity. How far up does this graph go? Well, it goes up forever and ever, so it'd be positive infinity. So there's your domain range. We'll get to set notation here in a moment. Now let's look at E. Is this one a function? Can I ever draw a vertical line that crosses more than once? No, so that's good. So this is a function. So now let's ask ourselves, how far left does this go? So how far left does this go? It goes to negative 5. Okay, now there's an open circle in negative 5. That means it does not include negative 5. So I'm going to put a parentheses, negative 5. Okay, parentheses, negative 5, because it's an open circle there. If it's a closed circle, I put a brace. So for domain, it's how far left to how far right. So how far right does this go? Well, on the right side, notice there's an arrow. So when does this graph stop? It never stops. So this graph goes to infinity. Okay, and we're going to put infinity with the parentheses because infinity is not an exact location. So domains, how far left to how far right. Now range is dealing with the y, so it's how far down to how far up. So how far down does this graph go? Well, it goes down forever. So negative infinity. How far up? So how far up, how high does this graph go? Well, this graph goes all the way up to 4. Now it actually hits 4 exactly. So if it hits that point exactly, we're going to put a brace there because it hits that point exactly. It includes 4. So we include 4 in the range. Now let's look at f. So is it a function? Can I ever draw a vertical line that crosses it more than once? No. This is a function. Interval notation. So domain, how far left does this graph go? So how far left to how far right? So how far left does it go? Domain's in terms of x, range is in terms of y. So how far left does it go? It goes to negative 4. Now it's got a closed circle at negative 4, so I'm going to put a brace at negative 4. How far right does it go? How far right does it go? It goes to 3. Okay, brace there. Okay, because it goes to 3 and there's closed circle. Range, how far down does it go? So range is in terms of y. So how far down does it go? It goes all the way down to negative 4. How far up does it go? So how far up it goes? This is the highest point, and that's at 5. Okay, now we've got to talk about how to express this in set notation. Okay, now for the domain, you will start it out with a bracket. I'm not sure what you call that, a bracket there. And you're going to put an X, and then you're going to put a vertical segment. That vertical segment means such that. So all these are going to have a bracket, X, and then vertical segment. Vertical bracket, X, and a vertical segment. This vertical segment means such that. Okay, so X such that. Now, I've got to express this basically as an inequality after this. Now, here's how you do it when it's negative infinity to positive infinity. From negative infinity to positive infinity, what you do is you'll put X, you'll put this E, which means it's a member of this weird looking E. It's not really an E, but it looks like an E. And then double bar R, which means X is a member of the real numbers. Okay, sometimes you might see this as all real numbers, or in an activity where it'll say like all real numbers. Okay, basically it's all from negative infinity to positive infinity, you're covering all real numbers. Okay, now next, another possibility is you could have where it's infinity on one side. So if it's infinity on one side, you're going to have an inequality, okay? So it's infinity on one side, so you're going to make just a simple inequality. Okay, so I'm going to do an inequality x and -5. And I'm going to do something in terms of -5, and I'm going to think, if I'm going from -5 to infinity, what values think about an inequality sign I could use to express from -5 to infinity. That would mean x has got to be what in relation to -5? It's got to be greater than -5. So it means x is greater than -5. Okay, so x is greater than x. So you make an inequality that satisfies this interval. So if I'm talking about from -5 to infinity, that means that x is greater than -5, because any value greater than -5 would be in that interval, okay? Now, whenever you've got an interval, so you do a simple inequality when you got infinity on one end of the interval. When you got two values it's bounded by two values within the interval, you're going to do what we call a compound inequality. You've seen this before. And so I'm going to put -4 beginning, x in the middle, and then 3 on the end. Okay? And what I'm going to do is I'm going to put two less thans. And I'm going to ask myself, does it equal any of those values? Well, it could equal -4. It could equal 3 because we had closed circles there. So I'm going to put equal to. Okay, and here's how this works. Here's what this means. And that was not a good closing there. It's x such that x is between -4 is less than or equal to x, which is less than or equal to 3. What does this mean? This means x is bigger than or equal to -4, but it's less than or equal to 3. Okay, so it's bigger than -4, but less than or equal to 3. So it's between -4 and 3. Okay, let's see if we can try to do this with the range. Now the domain deals with x. So what's going the domain or range going to deal with? Range will deal with y. So put y here such that y such that. Okay. Now, anytime it's from -infinity to positive infinity, you're going to do y is a member of the real numbers. Same thing as all real numbers. So it'll kind of mirror that. Okay. When the infinity involved, it's just a simple inequality. So I got y and 4. And so I've got to make an inequality that satisfies this interval. So if I'm going from -infinity to 4, what are those values going to be? Well, they're all going to be less than or equal to 4. Equal to because we include 4. Less than because anything less than or equal to 4 would be in that interval. So like -2. That would be in the interval. -100. Okay, so any value less than or equal to 4 is in that interval. Now, when you're bounded between two numbers or two values, two finite values, you're going to make a compound inequality, -4 and 5, and then it's your equal to, so it'd be put two less than or equal to's, and so y is bigger than -4, but it's less than 5. That'd be your answer.